We have been talking about quadrilaterals this entire chapter. We started talking about quadrilaterals in general. Then we introduced parallelograms, and for the last 2-3 sections, we've been focusing on parallelograms. And we talked about the different subsets of parallelograms. Rhombi, squares, rectangles, okay? So in that huge class of quadrilaterals, parallelograms are just one part. You've got all sorts of other four-sided figures that are not parallelograms, okay? Two specific ones that are four-sided but are not parallelograms are the trapezoid and the kite. So that's what we're going to talk about today, trapezoids and kites. So just remember, these are quadrilaterals. They have got four sides, but they are not parallelograms. Now, how did we define a parallelogram? It was a quadrilateral with what? Both pairs of opposite sides parallel, okay? Both pairs of opposite sides parallel. Now the trapezoid has a huge difference. This is a quadrilateral with exactly one pair of parallel sides, and I can't stress that enough. Exactly one pair. Remember, one more time, we've come across the word exactly several times now in geometry. In math, exactly is not a word to be taken lightly. It means exactly. So when I say exactly one pair, I mean there is one pair of sides that's parallel, but not more than one pair. Okay? All right. Those parallel sides are called bases. Okay? So four sides. If two of them are parallel, those are the bases. That leaves another two sides. Those are not parallel. We call them the legs. So the legs are non-parallel sides. What would happen if the legs were also parallel? What would the trapezoid become? A parallelogram. All right? Now, there are two pairs of base angles formed by the base and the legs. Okay? So if you take this first base here, and literally most of the time they're called, base 1 and base 2. If you take this one base along with the two legs, it creates, I didn't mean to do that. It creates base angles. And if you take the other leg, the other base, it creates another pair of base angles. Okay? All right. So what's an isosceles triangle? Right, it's a triangle with at least two congruent sides. An isosceles trapezoid is a trapezoid with congruent legs. So the bases aren't congruent. The legs are congruent. Okay? The bases can never be congruent. Okay? Bases can never be congruent. Yeah, because if you have one pair that's parallel and congruent, what would that make it? A parallelogram. Okay? All right, so not a rhombus. Two consecutive sides have to be equal for a rhombus. Okay. So here's a theorem. In an isosceles trapezoid, each pair of base angles are congruent. So look, here's one pair. Those are congruent. That's really an issue here. Those two are congruent. And these two are congruent. All right, so the two angles on top are congruent. The two angles on the bottom are congruent. Okay, yes?
Aren't all angles, aren't all interior angles in a trapezoid base angles?
They are, but you have two different pairs of base angles. The ones that are at the one base are one pair, they're connected. The ones at the other base are another pair, they're connected.
But the pairs don't really matter unless it's an isosceles.
Right. Yes. Okay, yeah.
Can all four of the angles ever be congruent?
No. Because if opposite angles were congruent, then it would be a parallelogram. It would be a rectangle. Yeah.
Is every single trapezoid an isosceles trapezoid?
No. Because look at the one on top. The two legs are clearly not congruent. Okay?
So then for those, the base angles aren't congruent?
Right. Okay. The next one says, it's the converse. And it says, if each pair of base angles are congruent, then you have an isosceles trapezoid. So this is the converse of this one. Okay? Here's another one that's important. It says, in an isosceles trapezoid, the diagonals are congruent. Okay? In an isosceles trapezoid, the diagonals are congruent. And that does not make it a rectangle, because the theorem for the rectangle says, in a parallelogram, if the diagonals are congruent, then it's a rectangle. So for that, it first has to be a parallelogram. Yeah.
Isosceles, the definition of isosceles trapezoid is that the legs are congruent.
Yes.
How come, like if the legs are congruent, does that automatically mean the base angles are going to be congruent?
Well, with this theorem, yes. Okay. Okay. So, yeah. You tell me.
No, because that's how exactly what.
Right. Okay. Okay. So here's an example. It says EFGH is an isosceles trapezoid with bases EF and GH. So if you have to draw one, here's how it would look. EF, GH. Okay, so bases EF and GH. Okay? And, oops, where did this go? Because it's an isosceles, because it's a trapezoid, the two bases are parallel. Now it says find the measure of each base angle if angle E is 7x and angle G is 16x minus 4. Now, we know that the theorem says that for an isosceles triangle, an isosceles trapezoid, each pair of base angles are congruent. So if that's 7x, then this is also 7x. Now, a trapezoid has parallel lines with a transversal. So we use our theorems for parallel lines and transversal. These are consecutive interior angles, so they are supplementary. That means 7x plus 16x minus 4 are 180. What is this? 23x is 184, so x is equal to 8. Now, if we have to find each of the angles, measure of angle E is congruent to measure of angle E equals measure of angle F, which is 7x, which is 56. Measure of angle G is equal to measure of angle H, which is 16x minus 4, 124. Okay. Please raise your hands if you have questions because I want to give equal opportunity. You can definitely do that. But then it would be like, yeah, it would be 2 of that and 2 of that equal to 360. Put away the cell phone. She said, can do all of them add up to 360? And they do. I was using the properties of trapezoids. Put away your cell phone. Okay. Any other questions before we move on? All right. This one is very, very important. And it shows up, you know, sometimes out of the blue. It's called the median of a trapezoid. Now, we've talked about median of a triangle. This is the median of a trapezoid. And it says this. The median of a trapezoid is a segment that joins the midpoints of the legs, right? So remember for the triangle, the median was a segment that joined the midpoints of 2 sides. This joins the midpoints of the 2 legs. So basically, you find the midpoint of one leg, you find the midpoint of the other leg, okay? And you join them and you get the median. When you do that, magically, the median will become parallel to the bases. Okay? All right, so here is, yeah. Yes.
Can you use the parallel you just made as like to make angles through and stuff? Can you use it as a parallel?
You can. Yeah. You can use parallels and transversals. Yeah.
But the one that we just made, let's say we need like have to I'm not really phasing out. Can I show you here?
Hang on, let me plug this in.
The trapezoid that you just did the median stuff with.
Okay, so this word should not be mid-segment, it should be median. And this one too. Okay, so here's the special thing about a median of a trapezoid, now that we know what a median is. The median is not only parallel to the bases, but its measure is exactly 1/2 of the sum of the measures of the bases. So basically, it's the average of the 2 base lengths. So if I wanted to find how big EF is, all I do is I add up the measures of AB and DC, and I divide by 2. It's literally the average, okay? So those are two things you have to remember about median. If I ever ask any of you out of the blue, what do you know about a median? It's the average of the 2 bases, and it's parallel to the bases, okay? All right, let's see where we can use that. So here you have a trapezoid ABCD. It says AB is 10 and DC is 18, and you want to find EF. Well, EF is just the average of the 2. Okay, so it's just 14. All right, now if you want it to go the other way for part B, if AB is 15, and now if you were given the median, okay, then you say EF is AB plus CD over 2. So 20 is 15 plus CD over 2. 40 is 15 plus CD. So CD is 25. Okay? So it's just like saying if you have 2 tests in a class and you want, or 2 quizzes and you want the average to be 20, you got one grade of 15, what should the grade be in the other one to get 20? Yes?
Is there a quicker way to find the DC on that one? Like, besides the way you did it?
I want to see some work. I mean, I know a lot of people can do it mentally, but I'd like to see some work. Okay? Okay. Next one. EFGH is now an isosceles trapezoid. So let's draw an isosceles trapezoid. EFGH. Again, it says EF and GH are the bases. And the median is YZ. Okay. Now, remember the median connects the midpoint of EH. So these two are congruent. To the midpoint of FG. These two are congruent to each other, but because it's an isosceles trapezoid, all 4 little segments are congruent to each other. Okay? Now you're also told that EF, and let's make the bases parallel so we know it's a trapezoid. EF is 3x plus 8. GH is 4x minus 10. YZ is 13. All right, and we know that the median is the average of the 2 bases. So I'm going to add the 2 bases and divide by 2. Now, to get rid of the 2, I multiply both sides of this by 2 and I get 26 equals. When I combine these, it's 7x minus 2. 28 equals 7x. X is equal to 4. So that was the first quadrilateral. The second quadrilateral we're going to talk about is a kite. Okay? Now a kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. And now we know what exactly means. 2 pairs of consecutive congruent sides. That means, if you look at this one, this pair of consecutive sides is congruent, and this pair of consecutive sides are congruent. All right? It has to be both pairs of consecutive sides congruent. Yeah. Yes. If a quadrilateral, okay, so here are 2 theorems for kites. And you just have to sort of memorize these. Flashcards, the whole bit. Okay? By the test, you should memorize them. Yes?
How do you know which sides are consecutive?
One after the other, so touching.
But like, couldn't it be like...
Well, if you turn the kite around, whoa, if you turn the kite around, then it could be these 2.
Like on the one that it shows, why couldn't it be AB and BC?
But AB and BC are not equal to each other. Right? If it was these 2 equal to each other, then it would look like this.
You just have to kind of like assume.
No, there is no. Okay, so there are 4 sides to a kite. Yes? You take one, it's congruent to the one next to it, and then you take another one, it's congruent to the one next to it.
But why can't the 2 that you just circled be congruent?
They can be. Like if I take this kite and turn around, then they would be.
Like, will you ever have to find?
Let's do some problems.
Okay.
You will clearly know because they're not equal. Like one is clearly bigger than the other. Yeah.
So you can just assume.
Let's do some problems. Yes. Let's do some problems. Okay. So here is a theorem. If a quadrilateral is a kite, then the diagonals are perpendicular. All right. So don't mix that up with the rhombus, but for the kite it's the same. And if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Just one pair. And usually, yeah, it's the included angle between the two, yeah, non-congruent sides. So here, let me write that down. So the angles that are congruent are where the non-congruent sides meet. Okay? So here it would be this angle congruent to that angle. Okay. Here I want to find the measure of XYZ. Okay? So where the two non-congruent angles meet is congruent. That means this angle X is congruent to which other angle? Z. So this is 121. Now this is a quadrilateral. It means all angles add up to what? 360. So 73 plus 121 plus 121 plus the measure of angle Z all equals 360. So we have 315. Y.
And also, can you do this measure of W equals Y?
No. Okay, listen to me. The congruent angles, okay, there is exactly one pair of congruent angles. Exactly one pair. Only one pair of opposite angles are congruent. The pair that is congruent is where the two non-equal sides meet. So only these are congruent. W is not congruent to Y. Okay, so in the one above, J and L are the angles between the two non-equal sides. Okay? K and M are not congruent. Okay? So 315 plus measure of angle Y equals 360. Measure of angle Y is 45. So you see how clearly it's not equal to W. Okay? All right, I have to do this other one. MN, I'm going to do it because I only have 3 minutes, okay? MNPQ is a kite. We need to find NP, this one. Okay, so MN, sorry. Okay, so this, I'm sorry, I was looking at something else. So here, we know that the diagonals are perpendicular, right? That means, if I do the Pythagorean theorem, and this is C, then 6 squared plus 8 squared is equal to C squared. So C is equal to 10, meaning MN is equal to 10. Okay? And if MN is equal to 10, then NP is equal to 10 as well. Okay? Now, this homework will be due, when did we say? Tuesday? I'm not finished talking. Hang on.